Hello everyone. So what's left from the front diff is to finish off the rear cross member. The front diff drop cross member is done. The rear cross member, the original one, is far off, and the reason for this is you can see how high it was, and if I was going to use it, I could have increased the pinion angle so much up the way that could have vibrations. So to have the perfect pinion angle, I have to drop the back as well, and currently in my setup that should be 5.6 degrees up. What I have discovered is there's quite a bit of flex here, and you can see the design. You have these dropouts and they're welded up here to the chassis, so that's where the torsion bars attached, and even without the torsion bars and without the cap on top, just with the engine, that thing is just flexing out. With the 35-inch tires and everything, that the load will be a lot higher. So my plan is I'll chop this off. They're too high anyway. So my mount will be here. It's exactly the same hole from the hole will be 50 mm lower. But first things first, I'll cut off this bracket and then take it from there. Right. So what I'm doing just now is making sure that the flange on the transfer case and the flange on the front diff, they are parallel. Before I continue with the rear subframe for the front diff, I just have to make sure that it's perfectly parallel on the horizontal plane, and then also if you look from the top, ideally you want the drive shaft to be perfectly straight, so there are no any compound angles like that or like that. Measuring for a parallel, they are 565 and 565 on the other side, so they're perfectly parallel. You can see my center line, and I measure off of that center line the distances for the drive shaft, the center of the drive shaft, the center of the front diff, and from the middle to the center of the flange on the transfer case. That's how I make sure they're all in line. So the next check is to see how far the transfer case, flange and the front diff flange are misaligned. They're parallel on this plane, like that. They're perfectly parallel, which is very important. That way the front diff is exactly 9 mm inside than the transfer case center line, which is fine. How I found that, you can see I have a plumb bob running straight through the middle of the shaft down, the same for the front diff, and then you can see the razor line. So this is showing 169 mm from the center of the chassis to the center of the front diff. From the center of the chassis to the center of the transfer case output flange is 177. Yeah, actually that gives us 8 mm difference in the center lines, which is fine. It's perfectly fine. As I said earlier, it's more important that the flanges are in line on the horizontal plane. If you have a flange like that, and then the other flange like that, and then on top of that you have also a misalignment on the horizontal plane, on the vertical plane, on the horizontal plane again, sorry. So these are too many compound angles, and they might have vibrations later down the road. So that's sorted, and I can finally start to do the rear subframe for the front diff. That bit here. Yeah, I've already cut it. You can see, just cut that bit from the original subframe just to use the bolt holes and the fixings, and then I'll integrate this to my subframe, which will be running from there, from that leg back to that leg here. Yeah, and the other thing I didn't mention is now the distance from the output flange of the front diff to the center line, left and right, is perfect. That's why I decided to leave the diff as it is. Otherwise, if I move the diff that way to have a perfect center line for the drive, for the prop shaft, for front prop shaft, then I will have this offset with 8 mm that way, which I preferably won't do. So that's all drivetrain squared up now. I'm good to go. Before I start doing the rear subframe, rear crossmember for the front diff, I have to sort out the angles, and it's very important because the front is a little bit different than the back. You've got that broken back configuration, or W configuration they call it also, because you have the output flange on the transfer case, it's pointing up, and then the drive shaft is going down, and then the prop shaft is going down, sorry, and then the front diff again is going down. So very important thing is to avoid any vibrations later on, and stress on the U-joint, on the U-joints is having the working angle here and working angle here in the front diff equal or close to within ideally half degree. So if you have opposite angles, like here you have opposite slopes, sorry, you have slope up and then slope down, you add both angles to get the working angle on that joint. And then here is the opposite, because you have slope down, so you subtract the angle of the front diff from the prop shaft, and you get the working angle there. So nice calculator that I'm using. It's the Spicer calculator. It's very simple to use, and you don't have to calculate anything. So I just did all the angles here. You can see the results, and the first one is the output shaft, i.e. the transfer case over there. Then the middle one, the 2.9, is the slope of the prop shaft, and then the bottom is obviously front diff, and you can see the slopes. This is obviously sloping up because it's the opposite direction, and then the other two, the prop shaft and the front diff, there sloping down. And that thing is calculating the angles for you. So you see I have the angles bang on, exact. I'll show you now. Yeah, so prop shaft 2.9 degrees down, and I've got a little drawing here. It's exaggerated, but you can see how the transmission is going down, and this is the output shaft, which is going back to the rear axle, if you imagine this, and this is the front axle. So yeah, so this is sloping up, and we need to find that working angle here, A, and the angle B, and you can see here the formula. Something's wrong. Yeah, that's 2.9 here. And that is 2.9. Yeah, so 2.9 prop shaft and front output shaft just have to be 2.8. I hope you see that. Yeah, 2.8, 4.8, sorry. And then the diff output shaft, the diff flange 10.6, and that give us the perfect angles. And yeah, so that's sorted. Once I know these angles now, I can figure out the cross member which will support the front diff here, and tying up this dropout and the other dropout there. Yeah, so I can start finally do that. So, what I've done off camera, as you can see, just cut off the old brackets for the cross member, and the plan is I have a plate welded on top of that plate, and also have the plate boxed this corner underneath, and you can see now actually how weak the design is. So you can see this is just hanging down, so all the torque from the torsion bars and all the suspension loads, they're taken from this, so there's a tendency for this thing to flex in and out quite a lot. And you can see here it's attached all the way up, and there's nothing to support it actually properly. And so the plan is, I've done this off camera as well, so this will be well like that. Yeah, the idea to have the return edge here is because, as you can see, where it is, yeah, see that's a plate welded here, but if I have my mounts attached to that plate, it could have a tendency to rip off that weld. So the idea of me having this return edge is I will weld that. Focus your fuck. Yeah, so that will be seam welded all the way up here and behind on the other side, and that will be boxed up here as well, so really rigid. Yeah, you can see how that's gonna be. And then on top of that I will have actually the cross member bracket, which will be welded from the chassis leg down to this plate. That will give it the proper rigidity. It was a bit boring to shoot this, but what I've done here is good at a good clean and spray it with weld through primer, because I've got these plates I knocked off the other day, and these are part of the whole bracing thing of these droppers here. So they will be seam welded here like so, and all the way tying up the bottom as well. And yeah, even though there will be a seam welded, I would like to have some protection in between them when I sandwich them forever eventually. Yeah, so the primer just set it's good to go, and I will just put a few tacks, and then I'll start building up the actual cross member mount, which will start from somewhere here and then continue here with that shape. Front diff, rear subframe done. What's left is just weld this here, so they will be all capped up and fully welded, obviously, the brackets to the chassis. But that's my version of the frame in the back of diff. A lot more beefier and stronger than before. I've done the whole subframe of camera. I just didn't have the camera yesterday with me, but that's the finished subframe for, or cross member if you wish, supporting the back of the front diff. And I just decided to make it all from scratch, and the mounts as well. They're much stronger now. It's a 5mm box. I just trimmed, it's not finished yet. It's just tucked in place, and I just have to cap this off here, and obviously fully seam welded. And the actual subframe is actually all done, all welded, with all the brace and whatnot. So yeah, I think that's it pretty much. I went for this flat design because the original subframe have a slope for some reason, but what my idea is, this is a perfectly flat surface now, and I've got the front subframe as well, so I'll run underbody protection, which will be bolt straight on that thing, and that'll be nice and flat. And I might carry on up to the transmission cross member as well. We'll see, but that's just the last touch. Yeah, so it took me a good few days, actually good few afternoons, but yeah, you can see from the top. And these are a polyurethane bushes. They're solid, so there's no movement at all. These are the drop bushes, so they're off-centered, so I can always adjust the pinion angle in case I decide to play with the but I think right now it's the engine and transmission is where they should be, where I want them to be. So it's, but anyway, if I decide for any reason to adjust any for the rear drive shaft, I can always adjust them from the bushes, because they're pretty much like on eccentric, and I can always play with them. The front bushes as well, they're diff drop bushes, again they're like an eccentric, so it's like pretty much a cam, and I can always adjust the front or the back of the diff at any point. So yeah, that's that done, and I think I'm up to the front suspension and steering, yeah. But I have to drop the body back on the chassis, so I can measure the travel and take it from there. But yeah, take shape.